Hello everyone and welcome to the Smart Factory Summit. So my name is Raik. I'm Vice President of Planning Solutions at Dualis. And as Alina mentioned, I like to explain you how we can boost up your shop floor resilience using agile disruption management and simulation. And I'd like to explain you how you can move from reactive firefighting more to proactive strategic planning. On the next 20 to 25 minutes, I will cover 3 topics. The first is we will have a look why resilience on the shop floor is so important. After that, I will explain you why the combination of ITAC MOM Suite and Gunplan is a good resilience weapon. And finally, I will give you a live demonstration and leave time for your questions. So then we come to the first topic. So let's have a look at the challenges. As you know, manufacturing operations today are under constant pressure. So from both sides, from external and internal sides. So when you think about maybe supply chain disruption, machine breakdowns, capacity bottlenecks, or maybe staff shortage with the reason illness or maybe qualification of the worker, or maybe you have unexpected regularity changes, or your IT system has a failure, and then you will see why resilience is so important for you. Because each of these issues can delay delivery, raise your costs, production costs, for example, and the most important thing, the customer satisfaction. And the question now that we like to answer is how we can help you to protect you against this. So, and we begin with what does this mean? What is shop floor resilience? So it's the ability of your production environment to resist and recover quickly from disruption. So without losing performance or production quality. And there are some few key reasons why this matters. Because minimizing downtimes, because every minute lost can mean maybe missed deadlines, or in the hard way, contract penalties. Then staying competitive. Resilient companies adapt faster and deliver more on time. So, for example, be a little more willing to take risks with short time delivery commitments because you know that these have been checked by an APS system, for example. And when we now have a look to our 4 main objectives, the first one is rapid response. So the system needs to detect and react to issues very quickly, because you don't have it's not good for you when the system takes hours to suggest solutions, because you can't wait so long. Then the continuous improvement. Learn from each disruption to prevent the next one. You don't want to fix the same problem over and over. You want a system that helps you to learn from the past. Then the resource optimization. You try to make the most of your resources, out of your resources. For example, machines, people, material, and in combination, and with stress in the production. Because you don't want to have a schedule, for example, with idle machines and overloaded workers at the same time. You try to have a good performance of both. Then the sustainability. Resilience isn't not about the next shift. It's about the long-term operational and environmental responsibility. So then we come to the MES and the APS. On the left side, you see an MES, Manufacturing Execution System, here with the ITAC MOM Suite or the systems from Axevo. And on the right side, you see the APS solution of the ITAC group, Gunplan. And how do we implement resilience? And the most effective thing is that we have a real-time integration of MES and APS. The MES give us the real-time view, what's happening in the shop floor now. And the APS give us the forward-looking plan. What should we do next? Let me give you 3 examples of these 7, I think. Yes. When a machine suddenly breaks down, the MES detects this in real time and alerts the APS. The APS can immediately reschedule affected jobs on the machine that's break down. Instead of a production stopping, your plan can adjust automatically with minimal disruption. Then the second example would be, imagine a supplier delays a critical raw material. The APS can simulate different planning scenarios. Maybe you can produce the same material with an alternate bill of material, for example. When it's not possible, maybe you have to wait for this raw material, but the APS decides which order takes place on the machine instead of the postponed order. So the system shows you the impact and the options. And so you can decide what is the best one for you. The third example would be the worker starts an order with a different setup on a machine that doesn't correspond to the planned order. So now the machine has a different setup. The APS gets these information from the MES and can do a rescheduling to the changed setup. And so you will get a new updated plan with a setup optimization sequence. And in all of these cases, the combination of real-time feedback and simulation-based optimization makes resilience so important. So, okay. So now we come to the software solutions. Now you see some of the functionality of Gunplan. So we have a very flexible cost-based optimization algorithm with 7 target criteria. For example, you see here on-time delivery and utilization, work in progress, setup costs, and so on. And you decide what is more important for you. We schedule against finite capacities, so work centers, workers, production tools, raw materials, and so on, and as well qualification of workers. So when a work center is not available because of breakdown, or maybe there is another operation already scheduled on it, so we are not allowed to schedule another maybe very important operation on this resource. So with that, we have an optimization along the complete value chain, not just for one department. So when the planners currently plan with Excel, for example, they have their department optimized solution, and with Gunplan we have the optimization for the whole plan. And with the bottleneck-based scheduling, we decide when you have to do what and not to produce or to produce parts too early before the due date. And as you know, when disruption occurs, chaos can quickly break out. But with the integrated systems and real-time transparency, you get the clarity you want. And you know where the bottlenecks are and what are the best options for you, because the system knows the machine states, the worker availability, the due dates, the production alternatives, and so on. And with the alerting system, with the alerts in the system, you get the information live from the system, and now you know when you have to act maybe in the planning system or in the MES. Okay, so now we come to one of the important things that I will show you in the live demonstration as well, and it's our scenario mode. With the scenario function, you have the possibility to do what-if analysis. So you can imagine this as a digital test lab, where you can explore the impact of the different decisions before you bring them to reality. let me give you some examples, and I will show you them in the live demonstration as well. So what happened if I add another machine, for example? Maybe is it worth or not? So, or is the bottleneck somewhere else? So maybe you can decide, okay, is it necessary to buy a new cost-intensive machine, or yeah, my bottleneck is somewhere else. What's with different shift models? So when you don't run 24/7 at the moment, maybe one shift per day, then you can decide, okay, maybe to extend the shift at the weekend. Does this one-off exception help you, or do you need to be to do this more often, for example? Or production versions? Is it possible to produce the product maybe with different routings or with different bill of materials? So the system can help you to find these solutions. So an example is, imagine you have you can produce the product on a slow manual work center. Yeah, it takes longer, for example. Or the alternative is, or a standard is, to produce it with a faster automatic machine. But when the automatic machine is totally overloaded, yeah, this can be a good alternative to go to the manual work center. And with these simulations, you get a deeper understanding of your system dynamics. And that leads you to get better and faster decision making when disruptions hit. So, okay, come to the again to the scenario analysis. You see on the left side some questions, and on the right side the answers for that. And the ability to test what if scenarios before you're committing is what you move you from hypothesis to reality. Instead of guessing how to change, you will simulate it. Yeah? And the result is that you have a smarter planning, less risk, and more confident execution. And when you remember, it's not just about solving the problems, it's about to preventing them, and you know how to react to problems. With the scenario planning and the continuous feedback loops, your team become more proactive. So not the firefighting from the beginning, you're more proactive. Again, three examples from the slide. When you see maybe an additional order in the scenario mode, you have the possibility that, for example, a sales guy likes to know what delivery date he can say to the customer for a potential new order. So you can check this with the with Scanplan in the scenario mode. Make or buy decisions. Yeah, you can change in our system the material data, so you can simulate what happened when you buy the material or you produce the material by yourself. What happened to your resource utilization, for example? And the third one, for example, is resource bottlenecks. Yeah, when you imagine you have a resource that is totally overloaded at the moment, but you know, okay, I have to do a maintenance on it. So what is the best moment? How does this affect the orders? They are already scheduled, planned on this machine, but you have to do the maintenance. But you can decide, okay, what is the best moment for that? So, and now I like to jump into my live system. So do you see now the browser, Gunplan?
Yes, we can see, Raik.
Yeah, perfect. So because I'm very good in time, so then I can explain a little bit more. So at the beginning, what do you see here? Yeah, you see our Gunplan software. It's the APS solution of the ITAG MOM suite, and we right now in the heart of our system, it's the Gantt chart. Yeah, on the left side, you see the resources here. Yeah, we have some filling. Again, give me 1 second. I zoom a little bit. Oh, that was the button I looked for. Okay, so on the left side, you see the resources. We see some machines. We see here 2 workers. It's a very, very small scenario, and we have some tools. So these resources are, all of them are limited. Yeah, you see in the Gantt chart, all the white spaces, for example, is free time. So we see, okay, our manufacturing zone don't have a shift model, for example. Here in the filling machines and so on, we see a shift model because we see, okay, on Saturday and Sunday there is no available time. But if I zoom into, for example, Friday, we see, okay, the machine is available from 6 to 11, 6 in the morning, 11 in the evening. And it's just possible to schedule orders in the free time. Yeah? So for operators, they don't like to work 12 hours, 18 hours a day. So here we have another shift model because they are just available until 2:30. They begin in the morning and they end up at 2 in the afternoon. And they have a lunch break here, lunch break, and then breakfast break, for example. So you can add all of these information in the MES, and we have it directly in our system. And this is very important for the planning, that we get a realistic outcome of the system. Because when I have a planning with an unlimited capacity, then the system says here, okay, produce everything on Thursday, but that's not possible, for example. So, and now let's come to one of my examples. We go to a different color scheme. You see here a lot of colored bars, random colored bars. Every bar here is an operation of an order, for example. If I go here, you see, okay, we have an order number here. We have setup and processing activities. I can explain when we have enough time. And you get a little bit information about the actual status. Yeah? Now we see, okay, this order is delayed by 14 hours. So, and now we see if I change my random color to maybe one of the nicest color schemes, it's a traffic light. Now I see, okay, everything what's green is fine. The yellow, orange is on time, so it's near to the due date. So they are not late, but they are far before the due date. And the red ones, they are not good. So, and now we see, okay, we have a lot of red ones here. So now we can decide, okay, what's happened when we have here, for example, in the assembly area. Here we have a lot of green, then yellow, and here red one. So now we can try, okay, what changed when we, for example, do an extra shift on Saturday. Give me 1 second, I will share again directly the browser because you don't see the bottom line here. Yeah, right now we see here we have 25 orders early, 6 on time, and 11 are late. So now we go to our scenario mode. I start them. And now I'm in a copy of my real system. So, and now I can do, for example, here, I go to the assembly area and add an exception for Saturday. So let's say, okay, on Saturday, maybe from 6, here, from 6 to Saturday, and we take 22. I add an exception maybe for work. So when I now apply this, now we see here we have a now free capacity. So now I'm able to move that manually, for example, to this free space, or I can do this automatically. So when I go here, now I'm in the scenario mode, and I create in the scenario mode a manual planning, for example. So because then we can easily compare the production plan to the manual result. So when I go here to the assembly machine, now we see here, okay, we have a gap, we have free capacity. I click on the resource, go to, where is it? Close gaps. Click on do it for everything. Yeah. And when I click here, now we see, okay, the free capacity is used. And when we go here to this chart, now we see here, that's our production plan. We know, okay, we have 11 late orders. And after rescheduling, okay, we have just 10 late orders. So on time 25 and on early 25, on time 6 and so on. And now I can add maybe another free space and can repeat this by if I want. And then we can check, okay, is it with these changes, do we have the possibility to reduce our late orders? It's one of the possibilities. Let me explain you something with the materials, for example. So I close this scenario file, so I'm able to maybe to save this, and then I can open it again and present them to a manager or someone else if I want to explain. Okay, the extra shift helps us to reduce the delayed orders. One possibility. So now I change this, and we go back to our production planning. And I change the color scheme to material. So now all of the orders they have the same material, gets the same color, for example. And give me 1 second, I have to check one thing. Okay, looks nice. And now we see, okay, we have here, for example, the refill red, for example. So we need red color. Here we have blue color. Here we have black color, and so on. So, okay. And we see here this little truck. We know, okay, we have here a delayed purchase order, for example, because I said the purchase order arrived at midnight, but it's not in the stock already. That's the reason for this icon. But what happens when one of these orders is delayed, for example? Because right now, as you can see here in the purchase orders, we see, okay, all of them have the delivery date yesterday, Monday in the night. But what happened when I changed this? So now we see, okay, here we have planned the red refill. Yeah. So what happened when I changed this maybe to Monday? So we get the information out of the ERP system that this purchase order is delayed, for example, by 1 week. And I changed this. But let's go to the scenario mode first. I go here inside, go to the purchase order and set. So we have to check which one is the red one. That's the black one. Here's the red one. So, and now I change this. Normally I get this information maybe from the ERP system, so I don't have to add this manually. And I change it by 1 week. So, and the result is very nice because I go in my system and now I get here an information, okay, the provision time of the purchase order is after the scheduled start of the activity. So that's a problem right now. So, but I'm in my production plan. So that's the result of the last scheduling. But I get information, okay, it's not possible normally because you have a lack of material. And now I can do maybe an automatic planning. I do this. And when you see now, red is a little bit behind and the gaps are filled with the black one. So we can have a look. Give me a second here. We can change this. Take a little bit here. Here we can. Here we have our production plan. So the base of our scenario, and with the planning we get the result. So, and what's funny, for our delivery, it's good that the red order is not on time because we have one operation less late than in the normal plan, for example. Yeah, here we have 10, and here in the production plan we had 11. So, and so you can check very fast what's happened when something is changing. So it's as well possible maybe to add here, because we have the time, I say, okay, Aaron is ill for 2 weeks, for example. So we go in our production plan and I say, okay, Aaron is sick. And yeah, I have to give me 1 second to discard the result before. And now I can change his calendar and say, okay, Aaron is sick for the next 3 weeks, for example. Say he is ill. So we get the information maybe from the MES or from the HR department, and they maintain it in the ERP system. Here we get directly the feedback, okay, we have an over allocation of Aaron. So because he is not available normally, but he has scheduled orders. And what we see is that all of the white spaces is gone, and he is available from Wednesday, 28th of May. And now I do my scheduling again, for example, and then we see, okay, Aaron is no longer used, but we have more late orders for sure, because Marley Ziegler has to do all of the work alone, without Aaron. So that's our very, very strong scenario mode. And as well, in the planning, so now I leave the scenario mode. In the planning, I have the same possibilities. I can do an automatic planning if I want, and then I have the possibility maybe to change the orders of the operation. So I'm very flexible. But as you know, we have delayed the delivery here. Yeah, so it's not possible to move the red before Monday, because the material is not available. And now I have done a lot of cars in my system, and when I like to get it repaired, I click on both machines, say repair my schedule, and everything is fine. So now the system tries to hold a lot of the orders that I have created manually, stable on the machine. So I've decided to change here from black to blue, and the system say, okay, it's your manual decision. I try to fix your violations in the plan, but you decided that blue is here better on the fitting machine 100, for example. Okay, so now I will end my presentation, and hopefully you have some questions for me.
Yes, Raik, thank you first of all. I will quickly share the presentation again. All right. Yeah, thank you. It was also interesting that you showed us the different scenarios in the live system. And we do have a lot of questions right now. So you can also yourself see it in the Q&A session if you open it. Yes. Let's start with the first one regarding to you. The first one is it seems to me that a lot has to be set manually for the analyses in scenario mode. Is there also some kind of automation for data maintenance?
Unfortunately not, because because every customer is different, and every customer likes to look for different scenarios in the scenario mode. So there's no possibility, for example, to whatever add one additional machine to every routing, for example, because every routing can be different. So maybe you have 10 injection molding machines, but you can produce 5 products on 5 different machines. So it's not possible to get a very flexible data interface for that. So at the moment, unfortunately not.
Okay, thank you. Second question is, now that we only talked about MES and APS, what role does the ERP system play in the interaction between the two systems?
So that's right. So normally in the data flow, the MES gets the information from the ERP system. So our data source is for 100% the MES. So we are normally only connected to the MES, but the MES gets the information out of the ERP system. So the MRP normally is done in the ERP system. So the ERP creates the orders, purchase orders, and so on. But the information is transferred to the MES, and so the information is available in Gunplan. So it's a very important role, but in the resilience, in the very short time flexibility to know, okay, in real time there is a problem on the machine. We get the information not from the ERP system, we get the information from the ITAC MES.
Thank you. One more question. Can planned orders also be scheduled in APS? If so, how does APS handle the changeover from a planned order to a released production order?
Okay. Yes, that's possible. And here's important. That is one important thing. An MES don't like a planned order because the planned order will be deleted by the MRP again and again and will be created with a new number with every MRP run. So for that, we have a bypass to the ERP system. So the 100% data source MES is not correct in this case. So we get the planned order from the ERP system directly in the APS, and we mix both of them. So we have the production orders and the planned orders in one system. And when a planned order is changed to a production order via the MRP, for example, or via manual releasing a production order, the production order knows which planned order is the base, and we have a solution for that we know, okay, now we can delete the planned order and use instead the production order. So that's possible, and we have done this at some customers already in combination with ITAC.
All right. Then let's cover also the next question. At the beginning, it was shown that Dualis can also serve different markets. If we have both injection molding production and assembly or metal processing in the company, can one and the same system be used, or are different templates required?
No, it's the same system. So because Gunplan is very flexible in how you can use it. So we have no one specific area where we use Gunplan. So we are in injection molding, electronics, mechanical work, and so on. So Gunplan is very flexible how you can use it. So it's possible to do all of them in one planning model. As you can see here, we have some filling machines. We have an injection molding machine, just a very small demo. And you see here we have a manufacturing zone. And all of these machines can have different optimization goals, for example. Injection molding, there's the goal to reduce the tool changes, for example. And maybe on a painting cabin, you like to reduce the color changes, and you like to have a setup matrix from white to dark, for example. That's possible.
Thank you. We still got time for a few more questions. What benefits would a manufacturer get from the Gunplan software if an MES solution is not available? Does it still make sense for an APS system to be placed?
Yes, for sure. What is important for us, so as I explained with ERP, MES, and APS as a data flow, nearly all of the information has its origin in the ERP system. Orders, routings, bill of materials, purchase orders, and so on. And for sure, it's possible to connect the APS directly to an ERP system. That's possible. But then we have to speak about how do we get the confirmations of the orders. So because when you only use an ERP system, normally the confirmation is not done in real time, or very often in a day, maybe just once a day, for example, and then you don't have this 100% transparency every time in the system. Because when we only get the confirmation at the end of the shift, for example, so we don't know, is this order started, is it finished, or whatever. But it's possible to connect the APS directly to an ERP system.
Okay. How is the planning horizon defined in APS? Is there a differentiation between operational planning and tactical planning? And what is the minimum and maximum planning period?
There is no minimum and maximum planning period because you can decide it. Right now in my demonstration, you see, okay, I have just 4 months here, 3 months. 1, 2, 3, 5 months. But we can say, okay, the planning horizon is the next 3 years. But you have to think about it's a detailed scheduling system. So normally the strength is to get right sequences on the machines. And you have to speak about the tactical planning. So what is the goal? Do you like to answer the question, is it more efficient to move a whole product line, for example, from one plant to another plant? That's possible with Gantt plan, but not in the same detail level. So normally we have a business logic before our planning system because it's very flexible. So we get the detailed information out of the ERP system, and we do the data a little bit more rough for rougher planning. So maybe we don't schedule on the specific machine. So we maybe schedule on a machine group, work center group, for example. We don't maybe schedule with the unique worker. So we schedule with worker groups, for example. So we do a rougher planning because the planning horizon is more longer. Because our system had no functionality to say, okay, I like to have the detailed scheduling just for the next two weeks and then do a rough scheduling. It's not in the same system, but it's the same tool. So that's possible, but we have to speak about what are the requirements for that in detail.
All right. Okay. I will pick one short question, and the other ones that are still open, we're gonna answer afterwards. Are there limits to the APS? For example, a number of machines or number of orders or other limits?
There's no limit at machines because if you have a lot of machines, it's good for us because the license prices are high. So that's good. And orders as well, there's no limit, so no hard limit. But when we speak about 100, 200,000 of orders, it takes longer to calculate everything. But the system will find the solution in maybe in shorter time or in longer time. Yeah. So, but normally we schedule about thousands of orders in under 1 or 2 minutes. So when we have 10,000 orders, it takes maybe 10 minutes to schedule them. But it depends on the optimization goals on the different machines.
All right. Okay. Okay, I guess this is it.